Alright, this is just a quick test of the calibration. So I'm looking at the voltage from a power supply feeding all 3 meters. And we can notice this is the meter that I used for calibration. So the SuperCap magic meter is calibrated to match the this particular meter at this particular voltage. This is one of the calibration points. So 0.2 volts is what we are trying to achieve to get 100 milliamps across the shunt. So that's an important voltage. If we go to, say, 0.1, it's off by a fraction of a millivolt there. And likewise, if we go up to higher voltage, here's 1 volt. It's off by almost 0.1 millivolts. But that is plenty good for what I'm doing. And I could spend more time calibrating. Here's 2 volts. But I want to get on and do some ESR measurements and some capacitance measurements. But it's roughly 4 digits of accuracy, and actually a lot higher resolution than that. It's got more digits of resolution if I wanted to show them, but obviously the accuracy isn't any better by showing more digits. Here's 3 volts. It can go up to 5 volts. And it's pretty good. I'm pretty happy with the way the voltmeter is working. Here's the kind of data that I was taking to do some calibration on the voltage. So I had voltmeter readings and SuperCap meter readings, and I computed the error, calculated some new offsets and gains to do a curve fit to make sure they lined up. Let's just zoom in here just so you can read the numbers a bit. But let's take a look at ESR. Okay, so this is the voltage which I normally start doing ESR at 2.35, and just this is so I'm just using a power supply here, and I'm going to run it through a 10 ohm resistor to simulate an ESR of 10 ohms, just to see what that looks like. So right now there's no current, so the voltage is just sitting at 2.35. When I turn it on to discharge, you can see here that the discharge current is 51.2 or 3 milliamps, and the voltage has gone down because it's dropping through a 10 ohm resistor from the source. But the key here is that the voltage that I'm reading is extremely similar. So this is now measuring the ESR, and if I do the calculation, it comes out to, let's just see if we can show it here. So I've got the no load voltage, the current at the voltage when it's under current, and then there's a delta voltage. So there's a difference between no load and coming through the and sinking 100 milliamps of 0.47 volts, and this is the DVM version of that. So there's no load and loaded voltage. The source resistance is 10.065 ohms, and that's what the ESR should be. But you can see here that after I did a little bit of a calibration, it's still 9.32 ohms. So the ESR is within 0.7 ohms at 10 ohms. So that's pretty good. I'm going to then run through all the capacitors over here and calculate what the ESR is for each capacitor. And I have the option to do the same calculation with the DVM, but that's a lot more manual because over here the magic meter is doing all the calculations for me. Alright, I'm going to demonstrate this SuperCap magic meter measuring some capacitors. This one is 10 farads, 7 farads, 25 farads, and 3 farads. Right now it's connected to the 10 farad capacitor and it's just measuring the voltage. So if I switch it to measure capacitance, it's charging up to 2.35 volts to get started with the measurement. And I've just displayed the voltage so that you can see what's happening. You can see that it's charging there, and then here you can see it's discharging, and the current is 104 milliamps. So that's it's doing its measurement while it's discharging here, and it's discharging down to 2.0 volts. And you can see the voltage is monotonically decreasing, nice and smooth. So it's saying it's 9.694 farads, and it's actually a 10 farad capacitor. So the meter is reading at least roughly in the right range. And maybe this capacitor hasn't really soaked for very long, so maybe its capacitance will go up a bit as it spends more time at voltage. And it's on its second pass now just to see if it's a stable reading. Coming down to 2 volts when it will update. And there we go. It's actually 10.089 farads on the second pass. So let's try this other capacitor here. This one is charging up again. It should be, it's at 2.3, trying to get it to 2, there we go, and it's now discharging and measuring. This is supposed to be a 7 farad capacitor. And that first pass is 6.634 farads. Again, none of these have been soaking at their rated voltage for long. I've been playing around with them and charging them up and discharging them, but they haven't been soaking. So now it's on its second pass here. .461 farads. So it's reading a little bit lower than the 7 farads at this point. Give it one more pass just to make sure that that's real. The next one, the 25 farad capacitor, will take a little bit longer. Yeah, so 6.58, it's sort of in the same range. Now, a bigger capacitor. And now it's all the way charged and it's discharging for its measurement. I may cut out a few seconds here and there instead of having you watch this thing discharge this slowly, but you can see that the voltage is nice and smooth. Even though it's going slowly, it's not jumping around, it's just decreasing steadily. The current is bobbling between 100 and 99 milliamps. But that's taken into account in the measurement, so it's measuring this all the time to make sure that it's always got the right current. And it's 40 millivolts away from taking a reading. There we go, and it's 25.973. So this is a 25 farad capacitor, and we're reading 25.973. We'll let it go through one more cycle, but no more than that because it takes a long time, just to see what the variation is between readings. Yeah, so I'll probably cut out the charging part because it takes as long to charge it as it does to discharge it. And note, this is in EDLC mode, and these are all EDLC capacitors. So it can discharge them down to 2.0 volts, whereas in the lithium-ion capacitor mode, this won't discharge them below 2.2 volts. So it's on its second pass here, finally. And there we go. So very consistent, 25.518 farads this time around. So let's have a look at the smaller one here. Here we are. Yeah, I find this carousel quite handy for doing the testing. So this one just went through one pass. It's quite quick, at 3.226, and it's a 3 farad capacitor. And the next pass is 3.192. So the meter is doing what I wanted. It's measuring capacitance, and it actually measures voltage extremely accurately. It's a good 4-digit DVM, up to 5 volts. So that's a demonstration of it measuring capacitance. I'll do a quick one on ESR next. So here we're measuring ESR at around 2.3 volts, and this is the 3 farad capacitor, which has a nominal ESR of 150 milliohms, and we're only reading 85 milliohms, so it's not really calibrated very well for ESR. Now let's have a look at a big capacitor here for ESR. This big capacitor has an ESR of somewhere around 35 milliohms nominally. And it's still charging up to 2.3 volts here before it gets going, and you'll see it switch to the discharge light when it starts taking measurements. Yeah, it does. Yeah, the charging goes up to about 2.3 volts before it gets going. There we go. So now we can see that it's taking a bunch of readings, and it's measuring 49 milliohms when it should be somewhere in the range of 35 milliohms. So like I said, I could calibrate these better. It's pretty tricky because the meter is trying to measure an ESR that's just a few milliohms, which is not an easy thing to do. So it's got very small voltage differences that it's dealing with when it's trying to measure ESR in this range. And I haven't really spent a lot of time on the ESR part of it. Well, I shouldn't say that. I spent quite a bit of time, but not enough time to get it really calibrated. So this is the 7 farad capacitor, which is supposed to be 80 milliohms, and it's reading 61 milliohms. So the readings are consistent. When I have a specific kind of capacitor, I get consistent readings on the ESR. It's just not calibrated to the right value. So here's the 10 farad capacitor charging up. It's going to take a bit of time. Here we go, starting to measure. And it's this 10 farad capacitor is saying it's 55 or 51 milliohms, and it should be, that's 60 milliohms. So this one is pretty close. So like I said, it's not terribly accurate, but it's consistent enough that with further work I could calibrate to make sure that it does read properly. However, I need to get on with some blogging, so we're going to stop calibrating and do that. Okay, so what I'm going to do is just run through the whole bag of capacitor, or the whole chassis full of capacitors here, and take some readings and populate the spreadsheet with all the values I get just to show that I'm taking some readings. But in fact, we're not trying to prove the actual value of the capacitance, because I don't have any way of confirming what the reading is on the meter. I can get readings which seem accurate enough, but they are not calibrated to any meter that is giving me a precise number. So I'm just doing it by calculation. I am sort of calibrating the voltages and the currents and the resistances that this thing is monitoring, but it's not exactly the same as getting a real capacitance reading for each of these capacitors. However, I'm really happy that I can actually take readings and get something that looks right, even though I can't confirm that it's precisely right. That means that the meter is actually useful for measuring to within the sort of nominal spec sheet or data sheet values of the capacitors. So if this capacitor was way off what the data sheet said, this meter would certainly show that, and it would show you how far off it was.